Thanks a lot first to SECPHO for this kind invitation to present our project, Qilimanjaro. So my name is Pol Forn-Díaz, and today I present myself as one of the co-founders of Qilimanjaro Quantum Tech. This is the startup in quantum computing with quantum annealers. So today I'm here to represent the company, and I want to explain to you what this project is based on, what are annealers, and why do we like them so much. So the outline of this talk is put together to basically answer the following questions. What is Qilimanjaro? Why is it different? Who is behind it? What is it doing right now? What will it be doing tomorrow? And what are the long-term applications? So let's begin with the birth of the company. So Qilimanjaro Quantum Tech was established in April 2019 in Barcelona. And is one of the few European companies on quantum computing and the only one based on quantum annealing. Currently, we have just closed the signature of the first two contracts for services in quantum computing. And also, we are part of a European consortium that is just being funded by the European Commission. I will tell more details about it later. So the Qilimanjaro as a concept exists since 2018, when we did a significant amount of dissemination. And this was picked up by the media, and in particular, the most important of the consultancy agencies that reported about us was Boston Consulting Group, that positioned us as an end-to-end provider, also known as a full stack, providing both software and hardware. So what is Qilimanjaro really about? Qilimanjaro sits on three independent legs, one on hardware, another one on software, and finally, third one on services or community. The hardware leg is about building a quantum processing machine. So this is a coherent quantum annealer that is designed to solve optimization problems. The key advantage of this hardware, our choice of hardware, is that it does not require quantum error correction. And this has an important consequence that it may be more scalable than gate-based quantum computers in the short term. I'll say a few more words in the next slide about it. So the second leg is also one of the key aspects of Qilimanjaro is the software. It is the development of quantum algorithms. But these are not the textbook quantum algorithms that you may know if you take an introduction to quantum computation. These are novel hybrid between classical and quantum techniques, in particular machine learning, to solve optimization problems and also quantum simulations. So the software team of Qilimanjaro is already working on several projects. The most important one of them is with a logistics company that operates in Barcelona. And finally, not less relevant, we have the community leg. So Qilimanjaro, we are developing Qibbo. This is going to be an open platform for the community of external developers that will allow running code on existing quantum computing platforms, also on our future quantum annealer, and as well as running a simulator, or also known as a virtual machine, that has some high-performance computing power behind. And all of this will be run through a cloud access. So let's now talk a little bit about annealers for those of you who are not so familiar with them. So what can you really do with annealers? So annealers basically solve optimization problems. And this may seem just one application may seem as not too much, but in reality, these type of problems are very ubiquitous in our society. And there are several areas where they have a strong impact. So first is the optimization of problems in finance, navigation, scheduling, but also traffic. There's already a lot of work, theoretical work that has been done in this area. Then there is the other big area, which is artificial intelligence or machine learning. And this problem can also be translated into an optimization by the training of a neural network. So there also a lot of potential impact here. Finally, the other area which is more challenging to implement is the simulation of complex quantum systems, such as molecules. So this area eventually involves getting access to new drugs, more efficient batteries, fertilizers, new gases, and along, etc. So some of these areas are also mentioned as applications from other quantum computing strategies. So let's position our project with respect to the existing environment. So before this question is raised, we do not compete directly against Google, IBM, Rigetti, or any other of the companies that you mostly see in the media, because we are not building a digital quantum processor, which is what their systems are. Annealers are analog quantum processors. And for starters, analog quantum processors are not universal. So that means that they are designed and they function to solve certain type of problems. Whereas with digital quantum processors, you can reach universal machines that basically they can run any classical and quantum algorithm. But not being universal has an advantage, which is that the hardware encodes the problem itself. So that means we do not require the quantum error correction, the correction of errors that come from the quantum state of the systems. Whereas universal quantum processors really need that. And this is the biggest obstacle to overcome. And it is at least 10 years ahead before this is really realized. So that means that in the midterm, annealers may be scalable, more scalable than universal quantum processors. Let me add that there are ideas to turn annealers into universal quantum processors, and also that there's a lot of work, in fact, on non-universal digital quantum processors. And this is where most of the research is happening, both at academia and in companies, but it's not clear that they may show an advantage over classical processors. So if you are familiar with literature in this topic, you will quickly say that there is a company that works with annealers, and this is D-Wave, and certainly it is. D-Wave has been around for about 20 years. And despite the controversy that surrounded them for some time, it is really admirable what they have accomplished technologically. Still, they have not been able to show that their machines so far are superior than classical computers that solve the same type of problems. The annealers we are building at Qilimanjaro are coherent quantum annealers. And that puts us in a qualitatively superior category in the degree of quantumness, if you wish. And this is in several aspects. The first one of them is the qubit quality. As our qubits are going to be designed to be highly coherent, and that means that they will retain the quantum information during the operation of the algorithm. The other big difference is on the circuit design that will result in more challenging operations to reproduce by classical computers. And therefore, we would be lowering the bar for a supremacy type of experiment. And then in the area of the algorithms, besides annealing and simulation, our annealer will implement variational algorithms. So this is one very distinctive feature. Still, D-Wave, after 20 years of work, D-Wave is at 2,056 qubits. So they have a good lead. But as you can tell, running all this show requires a profound understanding of quantum software and quantum hardware. So the team of people that has put together Qilimanjaro is complementing each other in all these aspects. So the acting head of the company is Dr. Victor Canivel. So he is a PhD in physics that switched to finances early on, and it has been in leading positions in companies such as HP, Silicon Graphics, Nikon, or Perkin-Elmer. The scientific lead of the project is Professor José Ignacio Latorre, who many of you may know. So he was at University of Barcelona until very recently, and now directs a new line on quantum computation at the Technology Innovation Institute in Abu Dhabi, and is the appointed director of CQT NUS in Singapore. So he's a theorist, as an expert in artificial intelligence, quantum information, and high energy physics. And in his career, he did his PhD at the UB, and he has been in important institutions such as MIT, CERN, and Niels Bohr in Copenhagen, before becoming professor of theoretical physics in Barcelona. Myself, I'm the leader of the quantum hardware team in Qilimanjaro, and I also lead the quantum computing technology group at the Institute for High Energy Physics here in Barcelona. So I'm an experimentalist, and that means I normally get my hands dirty in the lab, and my expertise is on the technology that we are developing in Qilimanjaro, which is superconducting qubits and superconducting quantum circuits. I did my PhD at Delft in the Netherlands, and then I spent some time at MIT, Caltech, and IQC Waterloo before coming back to Barcelona. Dr. Artur Garcia Saz leads the software team at Qilimanjaro, and he's also the group leader of the quantic group at the Barcelona Supercomputing Center. So he's a theoretical physicist, and he's an expert both in classical and in quantum algorithms, particularly machine learning. He did his PhD at SECPHO, and has spent also some time in North America. And finally, Jordi Blasco, he's our Chief Finance and Legal Officer. And so he's an expert in corporate finances, and he's the founder of Blasco Cellares and Ars Corporate. So with all these ingredients on the table, so what do we plan to do? So as I mentioned earlier, the company was founded in April 2019.
Paul, we have lost your presentation.
Really?
Yeah.
Strange.
Something strange happened. And we have a bit of noise. Sorry, we are trying to mute it.
Somebody should switch over the mic.
Elisenda, could you switch off this micro?
I'm on it.
Okay, is the presentation back?
Yeah. Thank you, Paul, and sorry. These are amazing days when we are working with children at home.
Yeah,
I don't know who is this.
Okay, so let's keep going. So as I said before, the company was founded in April 2019, and is actually a triple spin-off from IFAE, the University of Barcelona, and the Barcelona Supercomputing Center. So this alliance with these institutions allows Qilimanjaro to share spaces, services, technology, and personnel. We are working on an agreement with the Institute of Microelectronics of Barcelona for the development of quantum devices. At the end of last year, so we finally signed these two key contracts that I explained earlier that allowed us to launch Qilimanjaro. One of them is with a new international research institute, and the second one is with a logistics company. Just a couple of weeks ago, so the project of Abacus that was submitted to the FED Open call of the European Commission and is coordinated by myself through IFAE, has been approved. And this project is based on building a coherent quantum annealer technology, and Qilimanjaro will be a partner in this consortium, playing an important role. And right now, we're actually hiring. We are in the hiring phase, so we already hired the first 2 employees and look for another 5 hardware and software quantum engineers. So the scientific progress of Qilimanjaro partners has not stopped during this time. So what we have been doing is both in the software and hardware areas. In the quantum algorithms, Artur Garcia, the team of Artur Garcia, has made an improvement in the training of a quantum circuit controlled by a machine learning algorithm, while the team of José Ignacio Latorre that are working on demonstrating new applications on quantum computation have identified a data classifier algorithm, and these are some of the graphs that they produce with their algorithm. And I would say this is training using a single qubit only. but also they have found an algorithm that approximates functions, another one that gives a good estimates for option pricing in the stock market, and they have many other projects ongoing. So what about the quantum hardware? So this is where we are right now. So we have been temporarily working at the Institute, the Catalan Institute of Nanoscience and Nanotechnology, also known as ICN2, in the laboratory of Professor Sergio Valenzuela, where he has this kind of devices here. This is a cryostat where these experiments have to be conducted. The device we have been measuring, we have put together it's a single superconducting qubit. This here is an aluminum box, is a cavity, and the qubit is in this chip here, so this little dot in the center. And then if you zoom in, you see this junction. This is an aluminum on top of another aluminum electrode, and this is called a Josephson junction. So that's the key element of all the superconducting qubit technology. And with this device, we actually demonstrated coherent control of the state of this qubit. What you see here are the so-called Rabi oscillations, and they describe the evolution of the quantum state of the circuit from the excited state to the ground state and back. So this is the first ever superconducting qubit measured in the south of Europe, and is a big leap for us. And right now we are beginning to develop our first annealing prototypes. So where are we heading to? I'm getting to the end of this presentation, and this is the part that may interest most of the business people in this room. This is our roadmap. So right now, we already offer consultancy services in quantum algorithms and in technology transfer. And through our contracts, we have secure funds for the next 36 months. So our midterm vision in the next 3 to 5 years is to give access to this platform, QIVO, and also licensing technology to other providers of quantum computing. And here we are looking for additional funds. And later on, in the long term, beyond 5 years, we expect to start operating our large-scale quantum annealer prototypes, and then having the platform available for clients and academics for quantum computing services. So just to end, I want to stress that Qilimanjaro has a strong will to contribute to the generation of a critical mass in quantum computing in the Barcelona area in particular, alongside with the existing ecosystem. If you want to know more, please contact us and visit our site. And if you want, spread the word that we are hiring. So this is the end. Thank you very much for your attention.
Thank you very much, Paul, for the clarity explaining your roadmap. I think it was very, very clear what you are doing now. Thank you very much. And I want also to thank all the attendees for sharing the happiness of their children with the rest. These are strange days. Thank you. And those of you who have questions for Paul, please write down them in the chat. We don't have questions up to now. Is there any question for Paul? Just wait. We have one in the open. We have Martin Mariscal. He says, do you have any internship program in Qilimanjaro?
Yes, we are. It's not open, but we are expecting to have one put together at some point. Yes.
Okay. Anyway, Martin, stay in contact with
yes,
Qilimanjaro.
If you're interested, write us a message, and then we will let you know.
Okay. Domenico from QSite, how many qubits do you have now, and where do you fabricate your circuits?
Well, so right now we have this one qubit that I mentioned in the presentation. In terms of quantum annealers, we are not yet operating. I mean, all these contracts I was mentioning just started last month, so we are still putting together the team, but we expect that after the summer, hoping there will be no delays, we should start getting our 2-3 qubit prototypes. And then there was a second question.
Antonio La Laguna.
Yeah, the fabrication. Yeah, so right now we're getting the devices through research groups that I collaborate with for basic science. but the aim is to fabricate devices in the Microelectronics Institute of Barcelona, which is the SECPHO Institute in the campus of UAB in Barcelona. And part of the fabrication will also take place in our labs.
Okay. We have another question from Carlos Cano. Is your QIVO platform already open for the community? To the community? Sorry.
Not yet. No, it's being developed. This is the part that does not rely entirely on hardware, so we are working hard on making this one available. But I cannot give you a date yet.
Okay. Nicolo Somaski, which are the initial use cases that you will be addressing?
Well, in a way, we are already addressing some use cases with this, with the current basic science projects related to, say, pattern recognition, if you wish, scheduling, navigation, these finance problems of option pricing. So these are the ones that we're already looking at, but also the training of neural networks and implementing existing quantum algorithms using alternative methods that involve annealing.
Okay. Is there any other question? No? Yes. Antonio, annealer tech means the hardware is customized for each specific problem to be solved?
Not for each problem specifically. I would say it's for the class of problems, because
okay.
The annealers are let's say, they are very programmable, so you can control all the knobs of your system, and therefore you can encode a wide variety of problems. So it's more for the type of problems, not so much for the problem in particular.
Okay. Jad Sabek, do you think photonic platforms may enhance the performance of your hardware?
At this point, we only work with the superconducting devices. I didn't mention it, but they operate in the microwave frequency regime. And bridging that to optics is non-trivial. There's many people who are working on that to allow quantum communication of this technology, but so far it's still a bit early, but I do not see yet a direct relationship, a direct interest for just doing computing. For communications, definitely, but for computing, I don't see it.
Okay. Carlos Cano, can we find more technical information of your technology online, like papers or scientific publications?
Yeah, well, from the basic science aspects, you can visit the group website from the group at IFAE, which is QCT. So perhaps I can just type the address of my research group, so in case you are interested. And the group is quite young, so we don't have yet we have not yet produced a lot of work, but it will be in there.
Okay. Then if we don't have more questions, thank you, Paul, for the clarity, for your presentation. It was very, very nice, very clear. And we finish here with you, and let's go with the next speaker. Thank you, Paul.